Question number 41. A generative AI engineer building an LLM to generate an article summarized in the format of the type of poem, such as the Haku, given the article content. However, the initial output from the LLM does not match the desired tone and style. Which approach will not improve the LLM response to achieve the desired goal? See, the question asked is which approach will not improve the LLM response. So we have to find which option is not here is good for improving the LLM response, means LLM output. So option A, provide the LLM with prompt with explicitly instruct it to generate text in the desired tone and style. So if we provide the LLM to extract instruction and generate text into the desired tone and style, then definitely it will improve the response. And clear prompt engineering is the one of the most method to guide the LLM. So yes, this option will improve the response. LLM with prompt. So this option is not correct. For here only. You option B. Use neutralizer to normalize the tone and style the underlying document. This will not improve the LLM generation output style because a neutralizer affects the input document. But the problem is the LLM generates summary not matching the style. Making the source text more natural does not help for LLM to write the happy style. Means here we are just working on the input document. Neutralizer work to making the source to more natural. Right. So for that, what means we have to work on the output only. So yes, option B is not work for us, and I think this option is the correct answer for this question. Including option C, including few short example in the prompt to LLM. See, if we are giving the example, this will definitely improve the LLM output. So providing example shows the exactly what the tone and style we want. Option D, fine tune the LLM on the dataset to desired tone and style. This will definitely improve the response. Fine tuning directly train the model to produce output in the target. So correct answer is answer B. Use the neutralizer to normalize the tone and style underlying the document. Question number 42. Question number 42 is a generative AI engineer would like an LLM to generate formatted JSON format from email. This will require to parsing and extracting the following information like order ID, date, sender email. They will need to write the prompt that will extract the relevant information in JSON format with the highest level of output accuracy. Which prompt will do that? Option A. You will receive a customer email and need to extract date, sender email, and order ID. You should return a date, sender email, and order ID information in JSON format. This is good, but this but this only tells element to return the output in JSON format. It does not provide any explicit example what JSON would look like or like this, right? So this is good, but this is not too correct or too proper for here. Option two, in this, it's also saying that you will receive a customer email ID, need to extract dates, email, order ID, and format, and example also given here. So this is the best example. If you are providing the example, it will not extract the model to use the JSON format, but also provide the explicit example. So this is the correct structure, field name, and formatting. Correct, and LLM perform better if you are providing the example template or like this. So this is the good one, and this is the correct one. Option C. You will receive a customer email and need to extract date, sender, email, order ID, return the extract information in the human readable format. See, human readable format is not JSON format. So option C is incorrect. Option D. You receive customer email need to extract date, sender, order ID, return the extract information in JSON format. This is good, but less precious than B. Since its lack of the concrete example, so correct answer is option D. Question number 43. Question number 43 is a generative AI engineer building an RAG application that will rely on the context retrieved from the source document that are currently in PDF format. These PDF can contain both text and image. They want to develop a solution using the least amount of line of code. Which Python package should you use to extract the text from source? So the question asked is exactly which Python package is used to extract text from the PDF. So from the PDF, we have to extract the text and images. So which method is the correct? Which package is Flex? Option A. Flex is the web framework. It's not the use for PDF parsing and all this. Right. Option B. Beautiful Soap. Beautiful Soap is used to parsing HTML, XML, not for PDF. Right. Now option C is unstructured. Unstructured library is specially designed to negate and parse the document format of the PDF, Word, HTML. So if you have an image, so it will parse into PDF, means HTML and get the text from there. Means PDF, if you have PDF, Word or HTML or images as well, then it will give the text element with minimal code. Remember. So this is ideal for the RG pipeline since it extracts the clean text efficiently. Option D. NumPy. NumPy is the numerical computational library, not for PDF parse. So NumPy is also not. So correct answer is option C. Question number 44. Question number 44 is a generative AI engineer has been asked to design an LLM based application that accomplishes the following business objective. Answer the employee HR question using HR PDF documentation. Which set of high level tasks should you generate AI engineer system person? See, see the question is you are a generative AI engineer and you have a HR question answer PDF, right? And you in which you have a which set of high level of tasks should generative AI perform? Means what are the tasks you can perform from them? So option A, calculate average embedding for HR document, compare embedding to user to finding the best document, parse best document with user query into LLM with large context of window to generate the response to imply. So this approach only average embedding per document, not for chunk. It retrieves the whole document rather than a fine-grained chunk, which is less accurate. Partially correct, but not often. Option B. Use LLM summarize HR document. Provide the summarized document and user query into LLM with a large context window to generate the response to user. So this is spike retrieval entity. Simply summarizing everything upfront is the inefficient and may exceed token limit. So this is also not proper for the RAG data. Option C. Create interaction matrix of historical employee question and HR documentation. Use ALS to factorize the matrix and create the embedding. Calculate the embedding of the new query and use them to find the best HR document. Use the LLM to generate response to the employee question based on the documentation retrieved. Option C. This is approx correct, but not. This describes the collaborative filtering recommendation system, like altering least square, not a RG pipeline, right? So overlay complex and not assigned with the standard LLM retrieval method. Here is tracking for the LLM. Now option D is split HR document into chunk. This is something RG do, right? We get the document and split into the chunk and then embed into the vector stores. Yes, after chunking the document, we store into the vector. Okay, and vector search will retrieve the best. So use the employee question to retrieve the best, match the chunk the document, and use LLM to generate response to employee based upon the documentation retrieval. Yes, this is the correct answer because RG how works. RG first chunk the document, then embedded it and stored into vector database, and after that, for the means for retrieval vector search works, and once the retriever retrieve the proper question answer, LLM give the response basis of the zero angle between the question and answer. So correct answer is answer D. Question of 45. A company has a typical REG enabled customer facing chatbot on the website. Select the correct sequence of component a user sequence will go through the before the final output return. Use the diagram above for the reference. A. Embedding the model. B. Vector search. C. Context augment prompt. 4. Response generation LLM. See, so from the option, what we can say, embedding model. Embedding model is convert the user query into embedded and means vector representation, right? Now vector search. Vector search is the use the embedding to retrieve the most relevant document or chunk from the vector database. Context argument prompt. Context argument prompt is the combine the retrieved document with the original document. User query to the prompt and augmented prompt. And D response generated LLM. Parse the text argument prompt to the LLM to generate the final output. So basis of that, embedded model, then vector search, then contextual argument prompt, and the response generation. This is the response generation. We have response generation LLM. We have where it is in it is response generation in option A and option B. So embedding model in C and D is there in last, so that means C and D is not correct. Now we have option A and B only. We have embedding model. And first you can see first embedding model and then response generation LLM. First we embedded the thing, then we go for the search, then contact argument means correct answer is option A.